set in RStudio. That means last class also we saw that we have considered a data set, a sample data set, and we also performed the linear regression and also obtained the output, right? So yesterday also I started one more example, and only just we inserted, that means called the package, and after calling that we have taken only the data set. Okay, up to that everything was complete. So let's start again that one, then I will proceed towards other example, other practice session regarding the our lab, right? So everyone kindly open your R Studio. Let me share the screen. I think few new students have joined. I have not seen them earlier in early sessions. Okay. Okay. All of you just clear your console. Right. So in order to run the linear regression method, what is the name of the package that we want to install? We need to install. What is the name of that package? If you want to install, if you want to run a linear regression method upon a data set, then what is the name of the package that we need to install? I told in the last class also. Anybody, if you can remember, let me share the screen again. Okay. You can also, yeah, say tidyverse. Okay, good. Okay. So one question to everyone: if let I have installed a package in my earlier sessions or in my earlier programs, I have already installed a library or package. So if I want to use that package in the recent program, in the current program, what I need to do? I have, yes, that is library. Okay. So if means that I'm not talking about this tidyverse package, it is in general to every package. That means in your R Studio, if you want to work upon any predefined functions or any methods you want to use, and if for that you need to install some package, right? So whenever you install a package, suppose you want to use that may be in later cases. That means suppose I was working upon an experiment, and at that time I just installed a package, but after few days I need to work upon few methods that belong to that package. Okay, so as I have installed, I have not uninstalled, it has already been installed by me. So how can we use that? We have to call that package. That means we can do that using library function, or another function is there which call that as a require function to use the package that is already being installed by the user, right? So in the last class we are talking about the tidyverse package. So we all have installed that, so we do not need to install the package again. Those students we are not present in the previous class, you have to install the package. So for installing the package, the syntax is install dot packages, within bracket you have to write the name of the package, that is tidyverse, right? So after writing this you have to press enter if you are working upon the console part to run this statement. Those who have already installed from the previous class do not have to install it again, just call that library. Okay, so how we can do that? We have to write library, within bracket we have to call the package, right? So the package name is tidyverse. So everyone just do the same process. Okay, so that means now we have called this package, and you know that last class also I showed you the word file that I have already shared with you. So whenever you install or this package id was, whenever you call this package, you can see that the dp layer, the forecat, the ggplot, etc., all the packages are now available along with the tidyverse. So if you want to make use of any of the packages, you can also use that by calling those packages simply, right? If you have not installed, right? So that's why we are installing and we are calling this tidyverse function, tidyverse package, not function. Okay, so we have done up to this. Everyone follow the steps that I am writing here. Just do. Okay, you all have installed the package, so you have to call that package, right? So everyone do the same thing here in our R studio. Okay. Then, okay, so after doing this, I want to use a sample data set, right? So you can know the sample data set present in the R studio by writing the code, that is data function. Okay, so if you will write data within bracket, don't you do not have to write anything, then whenever you run this code, you can see that a number of data sample data sets are there along with the description. Okay, we have means many times have done the same coding, right? So you do not have to do that again. But if anybody is interested to find out the how many sample data sets are present, they can follow the same process. Okay, what is the function for that? For finding the sample data sets, that is data function. Okay, so let I am interested in working with the data set, sample data set, that is cars. So how we can write that? I have to write data function within bracket. I have to write the name of the data set, that is cars. Okay, let enter that. Then I have to write this cars. Okay, so whenever I will just press enter, that means I want to run this data set, that is cars. You can know, you can see that in the environment section in the third panel, you can see that cars is a data set with 50 observations and two variables. You can know that speed and distance are what? These are the variables and these are the observations. That means we have entered 50 rows against these two variables, right? So up to this, everyone is clear, I think. Okay. So did you get the same output? Okay. Right. Okay. So here we can see that those students who have joined here right now, that means the students having the first class here. I think many, a few students have joined. I have not seen them earlier. So let it be. So 50 observations are there with two variables, right? So let we want to work upon 10 observations. We do not want to work upon 50 observations. We want to work upon 10 observations, right? So how we can write that? We can write with head within bracket, we have to write the data set, that is cars, and how many observation we need, that is 10. Okay, so whenever I just press enter, I can see that my data set cars with first 10 observations are now here displayed along with the values. Okay, so everyone do the same process. Let me show the code this. Okay, do that. Did you get the answer? That I need 10 observations from cars data set instead of 50. So what I have to write first 10 observations. So I need to write head within bracket cars, the data set that I want to work upon and how many observations I need. I need only 10 observations. So I have to mention the number of observations here. So whenever I will just run this code, I can have 10 observations along with their values and the variables, right? Up to this, everyone is clear. Late, what another thing that I need to work, that here up to this everyone is clear, I need to create a linear regression model upon the data set cars, right? So for that, as we know that there is linear regression method, so we need one independent variable and the result will be a dependent variable, right? So as we are not talking about this multiple regression, in case of multiple regression, we need number of independent variable and one dependent variable. But as we are dealing with linear regression method, that means there we need only one independent variable and another one is the dependent variable. So we have, why we have chosen the cars data set, because it has only two variables. So it will be easier for us that we can take one as an independent variable, another as a dependent variable, right? So can you say among this speed and distance, which one is dependent, which one is independent? Yes, speed is independent because why it is independent? Okay. Yeah, independent variable means anything that we can change that. Okay, we can manipulate that. The speed, if we are driving, we can change our speed. Okay, change the speed of our vehicle. According to that, we got the distance. That means if we will just increase our speed, then we can cover the distance in a few minutes or a few hours, right? So the speed, the distance that will cover, that depends upon the speed we want to change. We can increase and decrease the speed. So that's why speed is the independent and distance is the dependent variable. Okay. So here, what we'll write, how we can just create a linear regression model. Yesterday, I told you one of the method to create a linear regression model using another data set. Okay, that was empty cars at that time. So many variables were there. There were 11 variables, if you can remember. But in this data set, it has only two variables. And here I want to tell you one another method. Okay, so that method we won't use. We have to tell another way of writing that how we can get the linear regression model, right? So here we are talking about the data set that is cars. So what will I do here? I have to write cars. See the process of writing cars, percentile, greater than symbol, then again percentile. Okay. What is the meaning of this one? Why we are writing this? By this statement, we assume that when we are here to create a linear regression model, data has no extreme values. Okay, that means there is the relationship between the variables. We are not taking any kind of variable, any kind of data that are not related with each other. So if that will be there, then we have to remove the outliers. Okay, so in order to do that, we are writing this cars percentile greater percentile symbol, right? Then I have to create a linear regression model for that, which function or which method I have to use, that is LM, right? So this is the linear regression. So it needs two variable. One is independent, another is dependent. And from the two variables we have, we know that speed is independent. So how we can write this? Dist. Okay, this is one of the variable. You have to see that is you are writing the same variable or not. Yes, this is the distance. Okay, let me distance. Then here tilde symbol, you have to write another, that is speed. Here you can say that LM is what is the method to create the linear regression, and it takes by formula, it takes two variables. Here, speed is called independent, distance is called dependent. So always LM function creates a linear regression model in R, and this function takes R formula. So this is what? This is a R formula, right? So this R formula consists of Y tilde symbol X, where Y is the output, that means outcome variable that we call as a dependent variable, and X is the predictor variable, that means the independent variable. So here distance is in the place of Y, speed is in the place of X, right? Then here up to this we are clear that we want to form a linear regression model upon the two variables, that is distance and speed. That means we have to find that if we are changing speed up to certain unit, how what is the prediction of distance, that means how we can just correlate with distance of the speed, right? So we want to find the relationship, what will be the value, what will be the prediction for distance if we will change the speed. Okay, so that this is our aim, that we want to get that. Then for this, we have to consider the data set. So let the data set will be stored in a variable that is called data. Okay. So here I have to write only dot. After that, I have to write percentile greater percentile. Okay. So here dot represents what? It will represent this car's data set, right? As we have written everything in the beginning, so we have to write here dot bracket close and this. Previous example, previous session yesterday, if you remember, we are not writing in this format. We are just writing here data is equal empty cars. If you remember that. Here, as we have written this in this way, that if we are getting any outlier, we can also remove. Then we have to write data is equal dot. And within after bracket, you have to mention this one so that we can remove the outlier if there is anything present, right? So after writing this, we have to write the summary. Okay, summary. Then press enter. Okay, up to this we have discussed also. So we want to find the summary of the entire model. We have to find the summary of the entire models. Here we have considered two variables, speed and distance. One is independent, one is dependent, and the data set we have considered as cars. And this is all about the summary of the entire model that we have generated. Okay, here anybody, just I think you have received same code in your R studio, just go through the code. Can you explain? I have also explained the same thing yesterday by taking another data set. Okay, the parameters or the things that were written was same, but the value is different because we have considered different data set. Okay, all others, this coefficient, intercept, speed, significant course, F statistics, that R is RSE, that means residual standard error. Everything is written same. That is same, but the value is different. Okay. So just read the code. After executing this, just read the code, and if anyone can explain me from the beginning what does this output say. Take your time. This is the output that is being displayed here. Just take your time. Just first of all, you understand as that I explained yesterday, line by line, and you then speak what each of the lines says. This 1Q, 3Q also explained by me. That is Q1 and Q3. Interquartile. If anyone knows the definition, or if anyone knows what the lines say here, then you can also explain that. If anyone is clear about this coefficients, if anyone is clear about these residuals, if anyone knows RSC, what is RSC, what is F statistics, what is the value, whether this model is significant or not, if anybody knows anything, can also explain. I am not saying that a single student will explain all the things. Just whatever you know, you just explain. See your code. What you have written, Sylvester? I can't get you.
Yes. Yes, residual is the distance between the actual distance and the interpreted value.
Yes. Yeah, residuals. Okay. You can also see that I have shared you a Word file, right? So that is same thing. The output is everything is written by taking one another example. You can also see, you can also refer that. Okay. I'm not saying to see that right now. Yes, you can also refer that. Yes, you want to ask me anything? Who has raised a
Uh,
hand? Yes, yes.
uh, I think I'll ask you at the end of the session, maybe. I have some two questions, dear lecturer.
Okay. Have you attended previous sessions?
No, because of
Yeah, yeah.
I couldn't
I
have
heard.
access to my account.
This,
So later
this is
on,
your
I have
first
to
lecture. This is your
connect.
first lecture you are attending.
This is the first lecture that I'm attending.
First
Also, there
lecture,
is
okay.
some time difference, and like I'm talking about the time zone difference between where I live and India. So, and also the other
You are
thing
from
is,
India.
I
You are
usually
from India.
travel in different remote areas. Sorry,
You are from India.
no,
Okay.
I'm from Somalia.
Okay. Okay. I think you have not installed R Studio. If it is your first lecture,
No,
that
not
means
yet.
okay, okay,
Today
okay.
is my first day, but I'm
Oh yeah,
watching
yeah.
the way you are doing the lab.
Okay. Did you watch the video lecture shared by the regional center?
Come again?
Did you watch the video lecture shared by the regional center earlier?
No, I'm going to watch it now because I've got
You
an
have not
email
gone through.
from.
You have not gone through the video lectures, right?
Yeah, I will watch it after this session. But now I was
Oh,
just I got the concept of the way you are doing the coding of the lab, so that at least I can try later on practicing of what you have done after you.
yeah, yeah. Okay. If it is your first lecture, you need to practice more because we have already completed, I think, 13 lectures I have completed. Let me show you. You can see also see that these are the portion that completed by me. I can see. Yeah. This is the first one is completed. First, second is also completed. Third, fourth, fifth. We are now performing here linear regression. Two examples I have written. First example is completed yesterday, and today I am explaining another one. So up to this, that means 11th number it is going on. Yeah. Okay. See, no issue. Try to understand. Okay. No issue. Yeah, we are asking about the exact meaning of the outputs. Okay, Anas told what is the meaning of residuals, right? Correct. Any other students want to say anything about what are the lines written in the output section? Those who attended last class, please. Here, residual standard error, that is RSC, is written as 15.38, right? So, if it is 15.38, then can you say that our model is very good? That the model you have generated using the data set, using the previous data, means the data set that is already present, that is cars data set. So, whether the model we have generated is the good one? No, no answer. Yeah, you can see also that here F statistics is 89.57. From here also you can say whether the model that we have generated upon the data set cars is good or not. What is the meaning of this 3 star? 3 star, this is 2 star. What is the meaning of that? This is 1 star here. Okay. Anyone want to answer? See your R studio, see the output. Everything is explained, right? No. Coefficients. Yeah, that is, here you can see what is written here. This is, let me show again. Yeah, this is multiple r squared and adjusted r squared. Okay, so I told you what this adjusted r squared value will consider when we will work upon this multiple regression. So as we are dealing with the linear regression, this is we will just work upon this. We'll just see this multiple r squared value is 0.65. That means 65%, right? Approx 65%. So this is what, this is one of the predictor. This says what is the variance that the independent variable and the dependent variable have. That means what is the difference between the independent and the dependent variable. It also determines that how well our model fits the data. That means here you can say that speed helps to explain some of the variance. What is the variance here? 65% of the variance within the distance. That means the distance, the difference or the variance between distance and speed is 65%. From the multiple r squared value, we can find out. That means this is not up to 100%. So that means we cannot say that our model is, that means fits the data. That means whenever we are taking the data of the cars model, cars data set, and we have generated this linear regression model, we cannot say that we are not sure that the model that we have generated is, that means fits into the data that we have considered, right? So here you can also see that is 89.5 cent. It is a large value, right? It is a large value. So it also says that this model is not good. Okay, it can be better, but it is not good as we have considered this cars data set. Okay, so that depends upon the data you have collected. If you have generating a model, that if the your model is good or very good, or if it is average one, that depends upon the data, the type of data you have collected. So it is giving us 89.57. That means the larger f statistics. That means it will say that our model does not fit into the data. It is not well, it is not a well built model, right? So here this p value is this much. That means it is less than 0.005. Okay, if you run this, it will be less than 0.05. That means we can say that we have to reject the null hypothesis. So null hypothesis says what? There is no relation between distance and speed. That means it will say that distance and speed are equal. That is no relation. But here we have to reject the null hypothesis as per the p value. Okay, at the p value we have received. That means from our study we can correlate that there is the relationship between speed and distance. If we will increase the speed, there will be some value of distance. If we will decrease the speed, there will be some value for the distance. Okay, that means here you can see from this coefficient portion, this is speed and intercept. So if we will increase the speed by 3.93 unit, this is what, this is in unit, right? So if we'll increase the speed by 3.93 unit, the distance will be decreased by, that's why it is minus, the distance will be decreased by 17.57 unit. Okay, that means the output says directly that there is the relationship between the speed and the distance. So this is speed, and this is the independent variable. And what is intercept here? When intercept is the outcome variable, that means it is the distance portion. So as we increase the speed, there will be the decrease in the distance. Okay, so this is the output. Okay, and that's very good. Okay, see, so yes, Sylvester, yes, you are getting error. You want to show me? Okay, 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 let me. Okay, Okay, so this is the code. Is equal dot. There should be dot. You can just compare this with the previous session, that means the last session. In the last session, we have written something in summary. Within summary function, we have written something, but here we are just following the other format, that how we can do another, what is the another way of finding this linear regression model. Okay, so this is the code I have pasted here. You can just copy and paste in your R Studio to get the output. What about others? Did all get the same output? Okay, so this is the entire summary that we have. Okay, I'm saying anything? Okay, okay, thank you. Okay, see, let I want to just, I do not want to find the summary of the entire. I want to find the summary of the model only. Okay, so let I am just assigning a variable that is mod is equal, right? So lm, there are so many ways of finding the linear regression model. So this is that I displayed, that was one method, and now I'm writing the another one. So if I want to assign a variable that is model, so mod, this is a variable. So mod is equal lm. Lm stands for linear regression model, and the variable that should be distance, same variable, and this is here tilde symbol and another words speed, right? And here data, we can write data is equal, okay, data is equal what, cars. Okay. I want to display this mod. Okay, so when I will display, I will get only the coefficient portion. Okay, so what is the impact? Because in linear regression model, we are just predicting the value of the dependent variable by working upon the independent variable. So if I want to know only the result, I do not want the summary. If you get the summary, it will show you everything. Okay, so but I do not know the, I do not want to get the summary. I want to predict the value only. So what I can write, I have to assign the same this linear regression model, the data set that we want to use, the variable that we want to use. We have to decide which one should be modified by us and what will be the result that we want to show. So everything we have prepared, and we have just assigned the value of the outside to the left hand side, and this is the variable that is mod, that is mod. So if I want to display that, I will display only this mod, then it will show me the changes in speed, because as we are considering it as an independent variable, how can you know that is written after the tilde symbol? So in a formula, this is what, this is the formula. So in a formula, if you have written anything at the left hand side of the tilde symbol, that is the dependent one. If you have written anything the right hand side of the tilde symbol, that is the independent one. So it says that if you are changing speed, what is the impact or what is the value that is predicted in case of distance. So this is what, this is 17.57. Why it is a negative? Because it, we are increasing the speed by 3.932 unit, the speed is decreasing, right? So this is one of the method by which we can form the value. We were interested in getting the prediction only. We are not interested in getting the whole summary of the entire model, right? So here also we can write. Or if you, after doing this, if you want to know the summary again this model, then how can write here? We can write summary, then within bracket the name of the variable where we have assigned the model. Okay, so entire model, this right hand side, the entire model is now assigned into a variable that is mod. So we want to know the summary of the model, that means we will assign mod variable within summary function, right? So here we have done. Then just press enter, then you will get the same summary that we have just got this, right? So same coefficients, intercept, RSE, significant codes, this R squared, F statistic. So this is also one of the way to get the linear regression model. So from the entire thing, what we can predict, we are predicting three things here. That the first one, if there is change in the independent variable, what is the prediction upon the dependent variable, what is the value, because in case of regression we want to know what is the value. We are not here to classify yes or no, true or false, like classification, right? So here we want to know if we have changed the independent variable up to this unit, then what will be the change, or what will be the value in case of dependent variable. So that is the first thing that we want to know, and we just received here in this intercept and speed value, right? Then another thing is that we are getting the residual error. Residual error means what is the distance between the actual value of the data sets, of the variables present in the data set. And if we are, because why we are doing the analysis upon the values present in the variable. Okay, so as you know, this is two variables are there, and 50 observations are there. So what we are doing, that we are considering the values, and we are just performing the analysis. So here we are getting that there is the residual error. Residual error you can also see from this one. Let me show you again. This is the word file I have shared with you all. You can also see. So this is the residual error here. This is the residual error. This is the actual value, and this is the interpreted value. That means the actual value, it is present in the data set, and whenever we generated the model using the same data set, we received some values here. Okay, so if there is the gap, there is, this is called residual standard error, that is RSE. So if there is no gap, you can see here and here three values are there. The actual value is same as the interpreted value. So we if we are getting much more RAC, that means residual standard error, so we cannot say that our model is good, because there is the deviation, there is the variance of the actual value that we have in the data set, and the value just we received after plotting, or after applying the model. So there shouldn't be much more difference. Otherwise, we cannot say that our model is very good at working properly with the data set, right? So this is the way. So this is the RAC. And another thing is that F statistics. So F statistics, this is the entire statistics of the model, of the linear regression model. And this says that if it is a larger value, we can say that our model is not good enough. Okay. So here also are getting the same, that the model is not good from this residual standard error. Here is also from the F statistics, we are getting that whenever we are generating a model using linear regression method upon the data set cars, but we generated the model, right? We have done this, it's okay, but this model is not good enough. This is not what as our expectation, because whenever we generate a model, we expect that the data we have considered, that should properly fit into the model, or our model works as per the expectation, as per the data we have considered. So as the data set we just fit into our model, and we are getting that the model is not working as per the data. There is no correlation between the data and the model we have generated. Okay, so this can be clear from the F statistics value also. And another thing that we can get from the summary, that whether the model will be that means the variables that we have considered, there is any relationship or not. We can see that from the p value. Okay, so if it is less than 0.05, we can know how we can consider. We have to reject the null hypothesis. If it is greater than, then we have to accept the null hypothesis. So as per the p value, as per the data we have in the data set, we can also get the different p values, and you can see that whether it is less than 0.05, greater than, or what. Okay, up to this we are clear. Any doubt, anything want to ask? Yes, yes, Sylvester, yes. Okay, yes, yes, Okay. See, yeah, whenever you are collecting data, that means whether you are working upon a project or you are working somewhere else, that means there are some parameters, right? So there are some variables. Suppose you are working in somewhere else, so if you have collected data, that means there are variables, and you have to put that this is the food intake, this is what these are the parameters, right? So as you can see that, let me explain this. So let this is the data set, so you will also collect the data set like this. So this will be the variables, and whenever you will collect the data, so you will have some variables, right? So against those variables you have to insert the values. Okay, so that depends upon what is your project, whether you want to find the, whether you want to predict the value on monthly basis, quarterly basis, or yearly basis, what you want to find. So according to that you can also correlate, you can also find the value that, what is that. See, the what you are working, this is your data set that is collected upon something else. So someone has collected the data and that person has fed the data into this, because that's why we are saying this is the sample data set. So whatever we are looking or whatever we are working upon, that is the data set prepared by someone else. Okay, so you can also prepare your data set by your own. When we are working somewhere else, very good, you just find out these are the my values, these are my variables, and according to that I have to fit the value. And after getting the value, just you see your, just you decide that what you need to do. That means you want to perform the regression analysis, you want to generate a model, you want to see that how this affects that one. Okay, what is the value if I am changing the value on x, what is the means prediction on the value of y. You want to get that, and you will surely get. And but you want to find that whether I have to do the same analysis for, means the, you have to fix the time, right? You have to fix the time. That, as I just understood from your question, that what you want to get, that you want to predict something, that you have to know that whether you are working upon that, the monthly basis you want to find out, or the gap of 2 months you want to find out. According to that you have to fit the data, you will get the regression model also. Okay, you try to do, this is the practical, right? You can do it by own, it will be very good. Sylvester, are you getting me? Are you getting me? Try to do. Yes, yes, try to see. I told you, you can also import the data set. Okay. So as you are working live, right? This is the live example, right? So what I am taking, I am not taking the live example. I'm considering the sample data set, because as I am taking the online class, this is my in my hand that I can give you an example. Okay. So if you are working live, this is the live data set you can collect. Okay. So it's very good. You just try collecting the data set, find the value, these are the variables, this will be the data sets. And what I can do, I have told you so many methods. You can also classify, you can also find the coefficient, you can also do the linear regression. Try doing this. And you just, if you find difficulty at any point, so you will just send me, you can just text me, you can just send me the file you have prepared, I will definitely help you if you stuck at any point. Okay, okay. Every I'm just asking to this to everyone, those who are working, you can prepare your data set according to the thing upon which you are working. Okay, so it will be very good for you. You will get a live example, you will get much more knowledge about how the things actually work. Okay, try doing this, Sylvester, and just prepare a data set, right? So after completing, you can just send me, or if at any point you are being stuck, then you can also ask me, that I will guide you that what can be done. Okay, see, next, this is the statistics, that it is the summary of the entire model we have generated. And if I want to find the attributes present in this model, okay, let me show you. This is the model that we have generated. Okay, And what is the name of this model? We have named this model as MOD. If I want to find the attributes present in this model MOD, then what I can write here? I can write attributes, okay, attributes within bracket the name of the model. So name of the model is here, we have just written MOD. So if I'm just pressing enter, I can see here that these are the attributes you can find. The coefficients you can know. See, this is the coefficients written, okay, residuals written. So these are what? These are the attributes of this linear regression model. Residuals, effects, rank, values here, and the call terms, etc. Here this is the call, this is what? This is also one attribute. So whenever you want to find the attributes present in a model that you have developed using linear regression method, then you can also write these attributes within bracket the name of the model that you have given. So as we know that I have named the model as MOD, so I can find the attributes by writing attributes within bracket MOD, right? So here, then I can also find the residuals only of this model that I have prepared. So how we can write that? I have to write here MOD. This is the name of my model MOD, and this dollar symbol. What I want to find? So these are what? These are the attributes. So let I'm interested in finding the residuals. So I will just click on this, press enter, then it will see this will provide us the residuals. Okay, so these are the residuals of the data set, that means the actual data and the fitted data or the plotted data, right? Not the fitted data. So the actual data and the plotted data, what is the residuals? Okay, residue, what is the gap? Is there any gap or not? So this will be shown by you, shown by this code, right? So you can say, you can know the residuals against the all the 50 observations by writing the code, the name of the model, dollar symbol, what you want to see. You want to see the residuals or the gap between the actual data and the plotted data. So you can get in this way, right? So we can also plot all the residuals, all the gaps, all the differences we have received by plotting the, that means by from the actual data and the interpreted data. We can also plot that in the, let we want to plot in histogram. So what we'll write here, histogram, this is hist, okay. Within bracket I have to write, I want to find the plot of the model, the name of the model is MOD, and which attribute I want, I'm interested in, I want to plot the residual. So what will I write here? Dollar residuals. Okay, this is residuals. So whenever you just click on enter, you can see here at the fourth panel, this is the plot. Okay, let's zoom it. Okay, residuals. So this is the way by which we can also plot. Okay, up to this. Yes, yes, yes. You can apply. Okay, I'm just showing you that how we can get the plot. You can also give the name of x-axis, that is x lab, y lab. You can also name the means give the title of this chart like man. Man is equal, within double quote you have to write. Okay, so the same thing that you learned in the previous section you can also apply with writing with comma. Okay, here you have to write here comma. Again you have to write hist within bracket mod dollar residuals bracket x lab. We have to prepare give the name of the x axis, y lab name of the x axis, and men. Okay, this is the name of the or title of this chart you can do. Okay, new student does not know anything, it's the first class, right? Okay, so he has,
Yes.
yes, he has to know from the beginning. Okay, so he has to know what are the various plots, how we can plot. Yeah, this is histogram, how we can represent, how we can represent the line graph, bar chart. So many things you have just studied. That he does not know, and this is the first class. Okay, he needs time. So what will be done in your case? You say me, the new student. What can be done in your case? How will you just get into all the things that already you touched?
First of all, I think I will have to put all my forces in rewatching all of the recorded sessions from the from the cloud, and then do all the practices and labs made by you while watching
See,
the videos.
in every section, in every sessions, I have explained everything. Okay, you try to understand. If you get any doubt, you try to understand from the beginning. Okay, so don't look for 2 to 3 days videos. Okay, try to learn from the beginning, so you will get this better knowledge. So in one day, you just try to learn one video. So after just going through those videos, so if you will get doubt at any point, okay, so you can ask me in the during the class also. Is he is added in the group, Sylvester? Okay, okay, okay. So if you'll get any doubt, you can ask me. Okay, so from the beginning, from the very first lecture, you have to watch all the lectures. Then at any point, at any time, I am just you can feel free to ask me anything at during the class or outside the class also, in the group also. So I will answer. Yes, you want to ask me anything again? Yes.
Sessions. Is there any other where that I can contact you through? I
Okay,
don't
okay.
know.
It
There
will
is
be
a
okay. Sylvester, please share the link. Okay, okay, okay. So that he will be added. Any other student was also there. I have not seen him earlier. He left also.
question you to contact me in person if you are available. I'm new to the session, and
Yeah, yeah,
for the past time, I was traveling, you know, continuously into different remote areas, and that was one of my
okay. Yes,
issues
yes.
that I have been facing through.
There no
Sometimes you
issue,
may.
no problem at all. I know everyone. I mean, when is working somewhere else, yeah, he or she has some issue. I'm not saying anything about that. I'm also working in an university, so I know what happens actually. So no issue at all. Okay, okay. You will be shared with the link. You can join. There we'll discuss that what can be done. Okay, right. So this is all about your linear regression, right? So we have completed with we are talking about CC, that means cloud computing and data science lab. We have completed this data science lab portion, right? We have done with the examples, we have done with the sessions, everything. So we have completed. So now we'll move towards cloud computing lab. So sir has taught you the cloud computing theory session. So you know very well what is virtualization, everything well. So I will just work upon the theory person, practical person, right? Sorry, practical person. Okay. So everyone, just now you are done with this R Studio. You do not have to do anything with R Studio. Just close this. Close this. We do not need this right now. Okay. Everyone, you do one thing. Just open your browser. We will just work upon this virtual box, right? So, what is the program? What is the next program? You can see from here that the next program is up to this we have completed, right? So, we have done with 11 experiments. Then the 12th one is related up to this, from this, which is related with cloud computing. So, okay, I'll share. Yeah, yeah, I will share. I will share. Okay. So here the next is how to install this Oracle VirtualBox, and we can create as per the lab manual you have in the site. So there is written that we have to install, we have to create this Oracle VirtualBox, and we have to create 2 virtual machines. So I will just explain you how we can install the VirtualBox, how you can create a virtual machine, and you just try to create another virtual machine. Okay, it is very easy. So first of all, it will take time to it won't take time to install the virtual box. Okay, so whenever you want to install any Ubuntu or Linux operating system, system. At that time, it will take time, but it is only, as per my knowledge, the file is 105 MB only, so it will be installed. Okay, so all of you just open your browser. Okay, so open your browser. Then we want to install the virtual Oracle Virtual Box. So what will I write? I have already installed. I will just guide you the steps. Then you have to install, and it will just like the other software installation. Very easy. You have to just press yes, next, etc. It will be installed. Okay. So right here, Virtual Box. Okay, open your browser, just write VirtualBox, and in the first side you can see that is Oracle VM VirtualBox. Okay, VirtualBox, it is there, VMware VirtualBox. Okay, so click on this. Then you have to click on the latest version is 7.0. You have to click on this, download VirtualBox 7.0. Okay, whenever you click on this, you can see that these are the platforms upon which this VirtualBox 7.0 runs. So as we know that we are working upon Windows. If